Let's talk about learning. I mean, really think about it. What's the best way to do it? Is it just about cramming your head full of facts, hoping they stick? Or is there a more powerful, more effective way to actually build knowledge that lasts? Well, today we're going to dive into exactly that. I want you to think back to your old science classes. Was it all about memorizing the periodic table and spitting back formulas from a book? Or did you ever get the chance to actually discover those principles for yourself? You know, that question, it really gets to the heart of this huge debate in education.
So you've basically got two camps. On one side, there's the old school model, what we can call knowledge replication. This is where the student is just a passive bucket, and the teacher's job is to pour in facts. But on the other side, there's a much more exciting idea, knowledge generation. Here, the student isn't a bucket, they're a builder, actively constructing their own understanding of the world.
And that second idea, this whole knowledge generation thing, it's all built on a really powerful theory. This is where it gets interesting. It's called generative learning. And honestly, it can completely change how you think about what it means to learn something.
So what in the world is generative learning? Well, as the pioneer M.C. Whitrock put it, it's not about a teacher just filling in gaps. No, it's a process where you, the learner, self-generate your own understanding. You take new information and you actively work to connect it to everything you already know. So you're not just absorbing information like a sponge, you're building with it, like an architect.
Okay, that all sounds fantastic in theory, right? But how do you actually do it? I mean, what does it look like in the real world? Well, it turns out there are some very specific, research-backed ways to make it happen. Researchers Fiorella and Mayer laid out 8 key strategies, and they kind of fall into 2 buckets. First, you've got the stuff you do inside your own head, the internal work. We're talking creating concept maps, drawing a picture of what you're learning, or even just imagining it vividly in your mind. Then you have the external strategies, where you have to make your thinking public. Things like summarizing, explaining it out loud to yourself, or, and this is the big one we all know, teaching it to somebody else. All 8 of these are like tools in a toolkit, and they're most powerful when you use them together.
So, you have these 8 powerful strategies, but how do you bundle them all together into something that actually works in a real classroom, day in and day out? Well, one of the best studied answers is something called the Science Writing Heuristic, or SWH for short. Let's look at how it puts all this theory into practice.
The SWH method isn't just a free-for-all. It happens in 3 clear phases. First, students get their toolkit ready. They learn the tools of real science, how to build an argument, how to speak the language, how to have a real scientific dialogue. Then comes the fun part, the argument phase. They design their own experiments and then have to convince their classmates that their claims are right using real evidence. And finally, they write a summary, not just for the teacher to grade, but for a real-world audience, which forces them to really boil it all down to the big idea.
And this quote right here, it just perfectly captures the heart of the whole thing. In a classic lab report, you might just list your data and call it a day. But with this approach, students learn that your data isn't evidence until you apply reasoning to it. It's not about what did you find, it's about what does it mean and how does it prove your point. You have to actually build the case.
Okay, this all sounds really good on paper, but here's the million-dollar question. Does it actually work? Does it create better outcomes? Well, to find out, researchers pulled together a massive review of all the studies ever done on the science writing heuristic. Let's get to the good stuff, the results.
And when I say massive, I mean it. They didn't just look at 1 or 2 studies. They synthesized the results of 81 different doctoral and master's theses. This is research spanning decades, covering thousands and thousands of students all over the world. From the US to Turkey to South Africa, that gives these findings some serious weight.
And the results? Honestly, they were jaw-dropping. Take a look at this chart. It shows the impact on critical thinking skills. Compared to the old way of doing labs, the SWH approach had what scientists call a very large effect size. Now that's just a fancy way of saying the improvement wasn't just a little bit better, it was huge. We're talking a massive leap forward. Kids weren't just memorizing stuff, they were literally learning how to think like a scientist.
But this might be the most powerful finding of them all. Over and over again, the studies found the same thing. In classrooms using this approach, those stubborn achievement gaps, between boys and girls or between so-called high and low achieving students, they just vanished. By the end of the school term, pretty much everyone was performing at a high level. This approach doesn't just help some kids, it seems to lift everybody up.
So, what's the secret sauce here? Why is this approach so incredibly effective? It's not magic. The research points to 4 absolutely critical ingredients that have to be there for it to work.
So what makes it all click? It really boils down to 4 things. First, time. This is not a quick fix. It takes about 18 to 24 months for teachers and students to really get the hang of it. Second, the quality of the questions has to change. You have to stop asking what's the right answer and start asking what's your reasoning. That leads to the third piece, the teacher's mindset. They have to truly believe their job is to be a guide, not a dispenser of facts. And finally, it all comes together with talk and writing, the simple, powerful act of making your thinking public, putting it out there so it can be debated, sharpened, and really, truly owned.
All of this leaves us with one last really big question to chew on. The evidence is overwhelming that this way of learning completely transforms science class. But if learning by doing, by arguing, by building your own understanding works this well for something as complicated as science, just imagine what else we could learn this way. Thanks for tuning in to The Explainer.